Hello, everyone. My name is Professor Victor Chang. I'm from the Tisa University, Middlesbrough, UK. I'm very honored to give a keynote today. And this is my second time to take part in this conference. And the topic for today is novel developments and contributions in Industry 4.0 for smart manufacturing, AI, data analytics, and security. As you know, the talk today will cover many aspects, and I hope that you will enjoy the talk as follows. Provide my talk as follow. I have provided some Chinese words so that IE is going to give people some knowledge and easier understanding regarding to the talk. So the part one is on the general understanding and overview of IIoT, industrial IoT for supply chain, and also the technologies and examples for part two. Part three will be on the future trends, and followed by summary, conclusion, and Q&A. And part one will be explained as follows. First of all, Industry 4.0 is a concept in 2013, starting from Germany. Then it has been developed under lots of different directions, and countries like China has been leading, and there will be massive development and improvement. And as we know, industrial Internet of Things can be divided into different streams. At the very beginning, people call it cyber-physical systems. There's been on the different categories with the structural health monitoring, track and trace, remote diagnosis, remote services, remote control, conditioning, and for monitoring, and so on. And as it has been developed into different layers, first of all in the industrial internet, and then well established into the industrial IoT. So to make all the physical and the virtual world to work together and to deliver the services together. As we can know, there are different services such as the energy company and the management. For instance, when a power plant with lots of electricity being generated and being kept under the monitoring control. So there are different departments, they're all in a pipeline. So that with the industrial IoT, it allows everything to be seen online live, so that we can then know different units, what they are doing, and with the progress. And if there are any problems, that can be reported. So similarly, with the IIoT for supply chain, it then connects all the different units and the people together, so the activities can be seen live. So it's very easy for the management. And especially with a modern world, there are greater demands for power and energy. So they will have to make it more efficient. And as we know, it's also important we do the survey. And we then have conducted a survey to know what will be important. So if for the mobile technologies of the industrial people, they say that more than 50% will be the most important for current users. And with the cloud services already very close to 50%, they are using cloud. And then with the RFID, although they are about 26.6% with the current users, but there are more people that will be using them. And then there will be other technologies such as the real-time mapping and global positioning. So as we know that the mobile technologies and the cloud services has been quite crucial for the development of the IIoT. And we need to know the technologies behind. For instance, in order to help us to make a better plan and to execute it. So we use the best practice approach. So they involve with analyze, create, communicate, aggregate, so that we then keep everything in loops for continuous improvement. And as we know, the IoT can transform with things and to give us what can be offered with then the commonly used things. So it then can make the cost to become revenue, to reduce the cost and to make more profits, and push and pull model, and to make the invisible to visible services. And of course, improve the efficiency to make differentiation, and with the new product and services leading to innovation, and it can be pervasive end to end and within the walls, and then it can be personalized. As we know that the IIoT cloud platforms were to allow us to connect different services and platforms all together. That includes the manufacturing and supply chain, with the extraction and heavy industry, and with the network infrastructure and sensor developers, and with the utility and smart grid, as well as the big data analytics, transportation, IoT, cybersecurity, and wearables. So in a way that it allows us to connect everything all together. And as we know, with the IIoT for supply chain visibility, it plays a crucial part because we order products and services and we expect the delivery. So every day there has been millions and billions of transactions, billions of deliveries from door to door and to the warehouse, so that we need to track all the products where they are. We need to know the vehicles are there on the road, and we then can do a monitoring, even starting from the warehouse to the customer or to the base. So then we then can analyze what, like the time taken, the efficiency, like how many goods can be delivered on daily basis, and then how long it would be taken from time to time. So then we keep track of everything, and of course, even we can begin from the production stage, when goods has been in production to the time that it has been into the manufacturing products in the warehouse and the distribution and to the store, so that every single step we will be able to track them and to see where the products and also our efficiency in terms of delivery. So in terms of IoT and its applications has been widely distributed, as we know that everywhere and everything has been well connected. So in a way, the energy and power management system will be very useful, because without having an efficient power, then first of all, there can be wastage. Secondly, you may have to buy more renewable energy sources or coal, petroleum, and so on. So in a way that it then connects everything from the users, that we then can even keep track of the electricity consumption to the storage, like how many should be stored, and then even the transmission, because from one to one, and there can be power loss. So then we then understand how many more power should be generated on hourly and daily and weekly basis, in a way that we then can connect everything here, and then we can even see everything live. Such as on the smart devices, such as on some monitoring systems, and even we can then work with smart vehicles. And in a way, IIoT has been very effective, because it then gives us the smart services in a way that it then makes our cloud services all together, so that we can connect to the smart city, smart hospital, smart highway, and smart factory, and so that it allows us, a city, to be able to think and act with a certain level of artificial intelligence, so that the medical services can be better running and efficient, so that we can then monitor how many patients they can be served, and in a way that hospital won't be too crowded, and then with a smart highway to avoid the traffic jam, so it then lead to the vehicles to the routes that will improve the traffic. And a smart factory will ensure that thousands and millions of products can be manufactured on daily and weekly basis. So in a way that it then can make the targets to be met. So everything is on the smart platforms. Everything can be on the smart services. And then on the part two, I'm going to talk about the technology examples. I hope my talk is not too fast due to the time limitation. So it's very important that we connect all different technologies together. One of the challenges that to get them together and as efficient, as excellent as possible. So the technologies behind involve AI, big data, the high-speed rail type of internet connection, or high-speed internet, and with the algorithms and the integration. So in a way, we then allows all the technologies to be together. So the different algorithms are behind. There are different types of the AI engine that calculate different types of demands. What are the requests? And then they prioritize to know what would be the most important, and then do accordingly. So they can be coming with different algorithms, like first come, first serve, or priority, or maybe a number of different combinations. Then with a high speed internet will allow the fast processing, and then the big data will then categorize what's important and analyze what will be needed, and to further process what will be required. And then we then can, from the beginning of calculation to the end of the products, and the services, you should not take too long. So in a way, we can deliver to the customers and to allow the service provider to know how well they can perform, and then they can improve. And then, as we know, the algorithm itself need to be better and optimized, because algorithm itself will be looking at the high side business network and low side business network. So on the high side business network means that these are on a priority. So the algorithm will then check with the high side participant, high side certificate authority, and the high side repository and processing platform. So in a way that it can then better process, further analyze, and to understand what the requirements are to deliver. So if your requests are on the low side, it will still be further served, except that it will probably take more time, and then to get a response a little bit slowly. So when we talk about IoT architecture for research, that especially in these days, there are different technologies like for computing, edge computing. So in our delivery, what we do is that it depends on the data. So the phone node is to communicate and collect and analyze different type of data in a way that we have a variety of things to get different sorts of formats and types of data. So one is on that, and the second one is on the high velocity of data generation. It depends on how fast the data can be. So the phone node will be collecting the data from that, and then the other phone node will be on the large volume data to ensure that different big data can be all collected. So in a way, from device layer to fog layer to cloud layer have all three major types of data. So in a way that we can better archive, store, and even we can then tag on for queries to understand what will be important, and we then can prioritize them further. So in a way that for user cases and for software today, it's highly crucial, because we need to know, first of all, we need to have the safety and the security, and also to understand the most important part of the data in order to store and analyze them. Because it's very important, first of all, we have to collect the real-time data. It's not an easy task, because there can be huge demands, and then can be also on the demand on the speed and efficiency and the speed you process data. And of course, the platform should be robust enough, because we have to ensure the security will be up to date, and to allow different types of analysis to be conducted, and the integration as well. And then you will then can be suitable for different types of application layers, and for the predictive modeling and predictive analysis, in a way that the user experience will be better and efficient. And of course, it should have excellent user experience in a way that we get communication. First of all, it's not too complicated. Secondly, you get the most important data on time, and that's crucial. And even for the businesses, we can also adopt the same strategy for the best practice approach. And then I'm going to give the example, because for this example, I'm going to give one for the manufacturing, because as the emphasis is on manufacturing, and in this day, the data has been a crucial part, because everything is digital. Therefore, for the manufacturing, these days, they call it smart manufacturing. They need to know how well they perform as a business on a regular basis. Even every day, they're analyzing data. So in this way, there have been data for the manufacturing organization. For instance, they have been involved in a big data project. So they have to analyze every single data point is a summary of the performance. Let's say this is the performance of the manufacturing for the product. And then after doing this for 50 times, then they can analyze, oh, this is the average or the mean performance. And then they can analyze, okay, most of the time they are within the 5% difference. And then you can analyze. So every major activity, every major manufacturing should be all sum up as a data. Then after running it 50 times or 100 times, they can begin to understand how well they perform. So in a way that they can also apply this example for business performance, because the business performance is a little bit different. Even you may have excellent tasks and achievement in manufacturing, doesn't mean your businesses are actually profitable. So in order to know, they are not only doing well in the manufacturing, they have to meet the business target. So what we will do is that we then have to make the actual rate of business performance, expected rate of business performance, a risk control rate. So risk control rate has to keep the risk in or within 2% in order to ensure that you do not have problems that become unmanageable. And then we then have to set the target, because every time to seek improvement, we have to seek a very, very specific target. And we have to understand whether we meet a target. So that it's very important to compare with the actual and expected business performances over a period of time. So then we use the 3D modeling to then show the improvement. We don't have to go through with the Excel accounting spreadsheet. So there is the advantages of doing so. And then we can also predict the risk value, because everything we do involve a risk. So we have to ensure that the risk is under the control state, such as under 5%. The American and European options allow us to then risk to conduct the risk modeling and analysis, because risk is fluctuating over a period of time. So every month is different. In some months can be higher, in some months can be lower. So then we have to keep track in real time. Then at some time we then can analyze every single activity we have done. So after running, for instance, if let's say you are running a manufacturing of the 40 different units, or maybe even 40 days, let's say after finishing all the activities. So what the manufacturing company do is that they understand the performance. Let's say now we need to know the performance of the manufacturing as a whole. Do we meet a target? Do we meet a target every day? And do we meet a target every time? Then the other type of target is that do we ensure that we are on a profitable side? We are not actually falling behind the schedule and demands. We are also meeting the targets. We are comparing between the actual and the expected performances. So we have to analyze all the data at all time. And at the same time, security is a very crucial aspect. As we have known, we have too much data these days. We have a lot of algorithm. We have the customers' data. We have the transaction data. We have different type of financial data. Therefore, it's very essential that we ensure the environment is robust and resilient enough. So my contribution is that I developed the multi-layer security that has been widely adopted these days. So the multi-layer security we involved with 3 major layers, with the access control and firewall, the intrusion detection and encryption. So the first layer is to understand who are the real users and to build a specific and highly customized firewall to ensure that only a certain type of data can be in and out. And intrusion detection and intrusion prevention is to ensure that there is a strong user identity layer. So only the person with the right access or what protocol can be allowed in. So if you are not using a certain domain for network or certain identity credentials, then the security will give you the alarm. Encryption, why is it on the 3rd layer? Because there can be some other files that has been compromised, or there can be some other malicious file that pretend to be the real one. So the encryption with advanced algorithms, they can detect whether there are any malicious file in disguise. So that is why multi-layer security is highly crucial in this, to ensure that there's a very, very high level of security. So in order to do this thing, when we have to do the simulation, first of all, we do the analysis for the data security and understand how long and what type of data. So that we then understand there are 3 types of data: data in use, data at rest, and data in motion. Then when we know the data security and the data center update. So how long you will take, how much time and how many resources is required. So in a way that then we analyze. So we simulate the scenario that if the data center is under a security threat and has been under major attacks, and then the data has been compromised a lot. So how long you will take in order to recover the data? So in the way that we calculate it, you will need at least 126 hours. So if the data cannot be fully recovered or cannot be rescued in 126 hours, there can be a risky position. So therefore, it's very important for us to know. So in order to conduct a test, what we did is that we developed virtual data center. Then we also perform the large-scale ethical hacking. So in a way that we have the viruses and Trojan that in the continuously attacking mode. So then against the multi-layer security, just to see how long it may break the security, and also to test the performance of the security to know how robust the security solution may be on offering. So in that way that we then keep continuously attacking over a period of time, we notice that there's a drop performance initially very close to 100%, like 99%, and then after 125 hours, it drops to about 78%. This means that if you do not rescue your data within 126 hours or 125 hours, at least there are chances that 22% of risk, because the performance of the resilience drops over a period of time. If you can recover your data in the first crucial, let's say 10 hours, you probably won't lose much. But if you cannot rescue all the data and get everything back to control within 20 hours, then there will be more and more things that they not be under control. And then the simulation itself, the workflow, it has only taken in about 2 seconds or less. So the simulation itself is not taking a long time. But the ethical hacking of doing work is to give the important messages. We need to rescue the data as fast as possible. So we also have done the ethical hacking to see how every layer performs. So the firewall can block more than 5,400 viruses and Trojans. So what we did was, as I have explained, just gave lots of viruses and Trojans of the previous year to see how robust your security can withstand with continuous attack. Then identity layer to identify there are more than 3,700 the fake profiles and the all the fake credentials, and encryption will detect about around 800 malicious files that pretend to be the real one, the good guys. So the multi-layer security in general can detect more than 99% of the fake files or malicious files in disguise. And then that is in 2012, we did the security performance comparison. At the time, a lot of security solution was only having one single security solution, one single layer. So the multi-layer security then performed better than a single layer security. Therefore, in a way that multi-layer security, it becomes a mainstream of the security. Then now let us back to the manufacturing today, because manufacturing today will give us certain shed light. So first of all, 76%, actually IoT can then make all the customer to understand what they like, what they dislike. Similarly, businesses can also understand the customers' preferences and behaviors. And then 66% is very easy for the IoT to measure the risk, to protect the company assets and improve the safety. And then 66%, the early movers say the IoT is very critical to competitive advantages. And of course, 61% of the people and the company that feel that IoT can actually improve the reliability or performance of the product and services. So now the warehouse these days is that you then can track the movements and the positions of the item you're looking in. And then because the warehouse can be huge, it may take a long time to get to the place that you want to take the item down. And even to find items, it may take a long time. So that now we have the intelligent smart wearable to identify where the location of the item you're looking for. So in a way that you can take it, and then the smart lift can actually get them on time, and there are also robots to take it. So a lot of manufacturing and warehouse these days are almost semi or fully automated. And as you can see, it's very busy in the healthcare logistics, especially at the time when you manufacture, and all the offices will involved with it. Because of the COVID-19 now, healthcare logistics is highly crucial because the pharmacy will work with a lot of drug and a lot of vaccines. So then when all the products has been manufactured, so let's say now you have developed the vaccines, then now you have to get all the delivery to be done. So in this way, that every unit, the activity can be tracked in real time, and they can be also analyzed. And from the time you receive the orders to the time it's manufactured to the time it's being completed and send it off, everything can be done in a day or so. So it will make the manufacturing process very, very smoothly and very, very efficient. Especially now, everybody almost is having the vaccines now. So you have to make it very efficient. And every day you have to manufacture many, many thousands of the vaccines. So you have to make it quick. So in a way, the IIoT will help us in the retail industry too, because you have different layers. First of all, with the sensing and actuating, we then get all the physical objects to different types, and like such as farming, food processing, distribution, and retail. And of course, we can then exchange data, and then we put it in a virtual object because we then can move this object around easily without taking lots of physical data. In a way that we can then integrate all of them. So the application services will allow us to have the information handling, problem notification, and decision making. So now I'm going to talk about the future trends. First of all, future trends is that we allows everything to be done and seen, monitor, and with the communications or completed on smart iPad or smart devices. Because now, imagine even the harbor or the ports have so many products in and out on daily basis. It's very hard to physically go there. And because of COVID-19, in some countries, you are not even allowed to physically go to certain places. So we have to manage everything on iPads. It will make life much easier. Secondly, the connected supply chain is all being streamlined all together because we then know what the other service providers are doing. We then know what other unit needs are doing. Then we then can have a good idea about the supplier networks, what they're up to, the raw materials, the contact, and then with the raw material inventory, how much the raw material will be available and what will be the resources required. And then we can then get connected with the production phases. We understand different units, what they're up to, what they have been doing, and the problems they have, and whether what we can help them. And then we have the products in and out, and transit stocks, and of course the customers, so that we then have the material flow and information flow. They can be all hand in hand. And then in a way that from the manufacturing to the customer, in a way, it's not taking a long time. It's taking only days. Of course, there are different technologies together, especially with the 5G and 6G. And then with the manufacturing system, now we rely on the high-speed internet and also the mobile internet through the use of 5Gs, in a way that we can process the data much faster because we have lots of sensors and they can get connected in a way that if there are sensors from the warehouse that can all store into transport and into the consumer and production layer, of course, that will be much easier. And the high tech will be the one behind to manage everything all together. And as we can see, the another future trend is that different processors can be further customized to suit individual needs. They are all in streamline from the vehicle drivers to collect to key attributes and to transmit to process and information. They are all in one hand and they can be all together very easily so that you can even check the progress on the smartphone. It's not going to take a long time. So the summary of my talk is that, first of all, there are three main topics of the IIoT for supply chain that have been presented and discussed in details. And then the second thing is that we have to keep updated with knowledge and skills in this area because there has been so many things has been happening on daily basis. And of course, it's unthinkable that a lot of this manufacturing can finish the product from beginning to the end. We are talking about days now. In the past, we are talking about weeks or months. And a long time ago, we were talking about years. Now, everything can be completed within days. Just like in mainland China, when you order something and then to deliver to your door is not taking a long time. There's expectation today. And of course, the third point we have to embrace for the future. such as the China's Manufacturing 2025 initiative, is not going to be stopped. And especially the recent news for the successful spacecraft mission and a rocket launch to build the station for the universe has been a successful thing. So manufacturing for China may be taking a lead in the world. So in a way that we can then work together with different people, especially with different clients and citizens. Of course, all these can lead to awards for publication revenues and excellent R&D output. So I have been working with different journals from time to time, and I've been giving talks for different conferences. I'm very honored. And of course, if you have any questions, you can then email me, especially my Gmail. Thank you so much for today. I wish you to have a good time. And then hopefully we may have the opportunity to talk. And thank you so much.